Now we're moving into the second half of the unit. So we're getting away from the nomenclature and the drawing of the organic molecules and looking now at how they react. The first part of looking at how they react is first figuring out where we get most of these from, what is their origin, and then how do we process them? Because when we get them from the ground or from wherever we might get them, they're usually not in the form that we really want them to be at yet. And so it takes a little bit of processing and things to get them to where we want to be. One key thing I think is important for you to think about is we'll blow through these fairly quickly, at least their origins. But each of them probably has a physical processing, which means we're not going to change their chemical composition at all. We're just going to be maybe sorting or moving some things around, but we're not changing chemically anything. And then there's going to be some chemical processing where we do turn them into different chemicals. We modify them into something more useful for us. So we'll keep those a little bit separately. There's the physical processing and there's the chemical processing. All right, so let's jump into this. The first thing you should know is where we get a lot of these molecules. So in your notes, you can follow along here. One of the major ones for Alberta and for a lot of places in the world, at least up to the last couple of years, has been coal. Alberta, up until fairly recently, was as much as 80% or more powered by coal-powered energy. So it's only now that we're starting to make the switch to natural gas in a lot of our power plants and things like that. But for many places, coal for a long time was the main source of at least of fuel. Maybe not some of the other chemicals we're going to talk about, but definitely for fuel. So the physical processing for coal, from this picture you can see, involves mining it. You've got to get it out of the ground. Now, traditionally, that was this guy with a pickaxe in a mine shaft. That's not really feasible anymore. It's not really cost effective. So most of our coal mines now look like that one over there. A larger kind of a open pit mine where we're just going to scrape it all out and sort out the coal from that system. So that's the physical. We got to mine it. We got to and then crush it up so that it burns well. Maybe sort out if there's other debris or things in with the coal. That's the physical processing. There's really no chemical processing needed for coal. But really, its only use for the most part is either producing heat or using it to create steam to generate electricity. That's really about the only use we have for coal, for the most part. There's a few little things, but predominantly. The next one is natural gas, and a lot of natural gas, you may have heard this term lately. It comes from fracking. And this picture behind me right here, in fact, let me hide my picture for a second. That shows fracking. And so what it is down at that bottom layer there, you have a shale layer or a rock layer where the natural gas is trapped in little bubbles inside the rock. So they drill down, and then they have, with special drills, they can now drill sideways through the rock, and then they set off little explosives that crack that rock layer. And that allows bubbles and things, those trap bubbles, to escape. So then they pump in water under pressure. They pump in little bits of sand that you can kind of see inside the crack there. That helps hold those cracks open. And then over time, the bubbles just kind of work their way out of the shale and come up through the surface, and then they can be captured and stored until they can be transported off. Now, not all natural gas is found this way. Sometimes we do find it in pockets where we just get it, and that's probably what we've done up until the last, I would say probably 10 years or so, was just we've found a pocket of natural gas. Now those are becoming a little bit either more rare or, in the very least, harder to get to. But we're finding that there's a lot of natural gas locked in these shale layers, and so there was a big boom in a little bit in Alberta, not as huge, but some, but North Dakota and some places like that where natural gas fracturing or fracking was really big there for a little while. Lots and lots and lots of new wells going in. Now with the price of everything, it's come down quite a bit. Not quite the demand there used to be, but but still busy. All right. The next one is crude oil. So this is where we drill down, and that can be on land with the pump jacks there, or even in water with an oil derrick, something like this, where we drill down and find a pocket of crude oil, and then we pump it to the surface. Both the natural gas and the crude oil have very similar physical and chemical processing that takes place into them. You can read about those in your notes. If you have any questions, let me know, but we'll just kind of keep moving along. And one that's important for Alberta is the oil sands. We have huge deposits of oil in kind of central and northern Alberta, but instead of it being encased in a rock layer, it's a crude oil like we would find in an oil well, but instead of being in a rocky substrate that we can get the oil out of, it's in sand. And so it's kind of like trying to get, if you took a sandbox and poured in a jug of water, it's like trying to get the water out of the sand. There's always, it just kind of sticks to the sand, and some of it you can't get out. Some of it you can easily, but the rest can be quite difficult. So this takes a lot of processing, usually using really high temperatures like superheated steam to get the oil to release from the sand particles so that it can be processed and turned into oil that then can be used. That leads to some environmental concerns, and you may have seen pictures of the tailing ponds that come from these kind of operations where that superheated steam water, by the time it's blown oil off of this, is really, really quite nasty stuff. In fact, in some cases they have gigantic man-made lakes of this stuff sitting there waiting for it to be able to be processed. And in the interim, while it's sitting there, they actually have big propane cannons to keep away wildlife and birds and things like that because the water is so toxic. Now, there is legislation that says that anything they do has to be cleaned up. So they've got to process that water, they've got to put it back. Even after this mining operation here, they're going to have to refill this hole and put in some dirt and replant vegetation and things like that. But there definitely is a disruption to that ecosystem, because this is you can see here, this is a massive operation. But a lot of Alberta's oil is coming from oil sands operations right now. So that's kind of the origin, and that's, don't stress too much about knowing all the ins and outs about each one and where they come from. But that's kind of a quick rundown of where we get a lot of our fossil fuels from, our organic molecules. Now let's move into the physical processing. The first one that you need to know about is fractional distillation. And this is where we're taking advantage of the difference in boiling points of the organic molecules. You remember when we went through the nomenclature and talking about boiling points, we said the bigger the molecules were, the higher their boiling points were. So what we do here, let me slide over a little bit so you can see this. Right here, we pump in superheated crude oil. So the oil that we get from an oil well or even from the oil sands. And it's crazy hot, like 350 degrees Celsius or higher, where if it can vaporize, it has. There's some here at the bottom that doesn't really ever vaporize, and it just gets pumped out the bottom. We call it the residue. That would be used for like tarring roads and asphalt and making shingles and stuff like that. But it's really thick tar-like kind of stuff. Everything else, though, vaporizes. It turns into a gas. And because it's extremely hot gas, it starts to rise up this tower. But as it rises, it cools off. The temperature starts to drop. So as it goes up, and now it's, let's say in this first chamber, it's maybe not hot enough for those really, really large molecules that have very high boiling points. They can't stay gas anymore. So they start to turn into liquid, and they land in this tray. And then it gets pumped out. And that would be things like fuel oil for maybe power stations or really big tanker ships or something like that. But everything else stays a gas, and it continues to rise up the tower. And then in this next chamber, now we get some slightly smaller molecules. And they now we've cooled down so much that we're below their boiling point now, so they condense back into liquid and then they're kept. And then we keep working our way up, getting colder and colder and colder, and for the most part we get smaller and smaller molecules. And if you look at the very top, the bottled gases, that would be things like the methane, ethane, propane, and butane, those first 4 carbons molecules that are gases at room temperature. So we would have to actually get them below room temperature or put them under pressure to be able to separate those. So they just stay gas all the way up and come out the top. So based on that, we've got, let me slide over here. At the bottom, you've got large molecules, really long hydrocarbon chains with very high boiling points. That's what we get at the bottom of the tower. And then as we go up the tower and the temperatures start to drop, we move from that to up at the top there, the small molecules with much lower boiling points. And that's just fractional distillation. It's a physical, remember, it's physical sorting. We're not changing any of the chemicals. We're just saying, oh, you're big, you go over there, and you're a little bit smaller, you're going to come over here. And we're sorting them kind of out into bins based on their size. But it's the differences in boiling points that allows us to do that. So that's the process there. Okay? The other physical processing is something called solvent extraction. Sometimes in that mixture of whether that's oil or natural gas, there's another chemical in there that we don't want. Something that maybe is either dangerous for us or harmful, or even just something that's not part of the mixture that we want, just something we want to remove. So in this case, we use a solvent to selectively dissolve the thing we want to remove and then take it out. And we can remove the solvent with it, and then what's left will just be everything else that we wanted. So the easiest way to think about this, I find, is if you imagine a sandbox, and imagine somebody dumped salt into your sandbox. You want to get the sand out, or the sand mixture separated from the salt that's in there, but you're not going to be able to go through and hand pick out every grain of salt. But if you took your sand and you put in a water mixture and stirred it around, the salt would all dissolve in the water and the sand would be left, and then you could remove the water. Now that might take a few rounds of flushing that out, but eventually the solvent, the water, would selectively remove the salt, or the thing that we want to remove out of that mixture. Now, that doesn't mean there's salt in the oil, but there's some other similar molecule that a certain solvent might be able to dissolve that thing and remove it out of the mixture. So that's what we'll stop for this video. That covers where we're getting these organic molecules from, kind of those fossil fuel bases that are the beginning point for a lot of our organic molecules, and how we do the physical processing of them. In the next video, we'll move on to the chemical processing. So if there's anything here that I went through too fast or it doesn't make sense to you, make sure you reach out. Hopefully, though, it all makes mostly sense. Like I said, though, if not, let me know.